This begins section 2.4 in Math 098, and just in case I haven't emphasized it enough, it's difficult because I know a lot of you, first of all, you have to take Algebra 2 in order to get to this class, so I know you're familiar with M is what we use for rise over run. You might even be familiar with the notation of change in y over change in x, which is this formula, y2 minus y1 over x2 minus x1. If you're curious why we use the letter M, this will never be on a test, but English is not the only language that does math. The French do as well, and their word for slope is monter, which it looks like it means to mount. To rise, to climb. Anyway, blame the French for why we use M for slope. But anyway, the important thing as you look at a few of these problems is whatever you name as x1, which I'm going to name as 4, then y1 also has to match up with it. So x2 is -2, then y2 is 3. So the slope of this line is y2 minus y1 over x2 minus x1. So the important thing here is the 3 and the -2 line up perfectly, and 0 and 4 line up perfectly. Then we get our slope of -1/2. Now, since it asks you to graph the line, it'll help you understand, because we're at 4, 0, and -2, 3, you can actually see that if you went down 1, right 2, down 1, right 2, down 1, right 2, they fall on top of each other, which needs to happen for a line. Same thing goes for the next one. Let me just change colors. Call this x1. That should have said y1, x2, y2. So your slope, if you're doing it my way, there's another way of doing it, by the way, just that's how I'm doing it. 5 minus -5. So this is why we make you do all of the arithmetic from an earlier problem. Reduces at 3/5. By the way, if you leave it unreduced, you'll get full credit. I'm just showing you what most math teachers do. So since we're asked to graph -5, 4, and then 5, 2, you can actually see that it's going up 6, right 10. Or you can do up 3, right 5, up 3, right 5, and they fall on top of each other. So that's why they want you to graph, is so you can visually see if you did it correctly. I strongly encourage you checking your work, by the way. So what about this next one? Well, it's tough when it's not in slope-intercept form, in case you forgot, even though we've already written it down a few times. Mx plus b. Basically, you have to solve for y. Well, how do we solve for y? It's always the same two-step process. You always add or subtract the x term over. Oh, but those aren't like terms, so we just have -3y equals. We just separate them, -2x plus 9. And your previous math teachers do a great job of explaining that to you. It's multiplication, so you divide. Now here's the thing, is when you divide, you want to make sure you divide by every piece on the other side. And what you're really doing is distributing -1/3 to everything. So what's the equation? Well, negative over negative is positive 2/3 x, and a positive over negative is -9 divided by 3 is 3. So what does that mean? Your slope is 2/3 and your y-intercept is -3. Let me write that out. Your slope is 2/3, your y-intercept is -3. That's all we have to do there. Sorry, my -3 looks wonky. Okay, so exercise 4, pretty straightforward if you ask my opinion, but notice that x in the problem is representing the year since 1980. So if we write x equals 1 in this equation, it's referencing 1981. So this population in the United States of people that are 85 or older, basically it's saying in 1980, year zero, there were 2,127,400 adults that were that old. And then 1 year later, well, 110,520 times 1 plus that will give you that number. So how many years need to elapse to get us to 2010? Well, if you're not sure, do 2010 minus 1980, and you'll see that 30 years have elapsed. That's what you need to plug in for x. And you already know what I'm going to do. I'm going to go to Desmos and plug it in. So that equation, I already forgot what it was. 110, 520. And I don't need it past this one answer. So I'm just going to type in the x value, 21274, I believe it was. There we go. So you can see 5,443,000. Age 85 or older. So what does this actually mean? I kind of explained the y-intercept already. Because the way the directions are set up, in 1980 is year zero. So it makes sense that 1980 is the starting point, or the y-intercept. So the y-intercept is the 2,127,400 number, and it represents 85 plus age people in the United States in 1980. So now I'm going to go back to letter B and explain the slope. Well, if the slope is like rise over run, this is how much they're increasing per year. So, slope, get in the habit of writing down a rate. And what's the number? It's 110,520. It's the rate of increase, and it's an increase because it's a positive number, of 85 plus in the U.S. And then use this word a lot, per, because it's a rate per year. So since 1980, which we kind of answer in part C. So these are the kind of words that I'm looking for when you answer these questions, if a word problem shows up on a test coming up. So moving forward, we've actually already seen problems like this. And just remind yourself, if x equals, that's a vertical line, and you should have memorized, since we did this in a previous unit lesson, that vertical lines have an undefined slope. Please, please, please do not write no slope, because when I hear the word no, I think of zero. It's very confusing, and I don't want to get into an argument. I will let you write down that the slope is undefined like this, because that is true. And same thing goes with the next one. This is y equals is a horizontal line, which we've already covered, has a slope of 0. Okay, again, try to avoid no slope, because I don't want that to be a catch-all for both of these. There's a big difference between an undefined slope and a slope of 0. Just please avoid writing no slope. I don't like it. So comparing slopes, just so we're aware, positive slopes are slopes that go up and to the right. I like to explain everything is to the right because we're always moving forward. Negative slopes are down and to the right. We already talked about zero slopes are horizontal lines, and undefined slopes are vertical lines. Okay, so parallel. I hope you remember this from geometry. Parallel lines have equal slopes, or the same. And the reason why I want to write the same slopes is because what about vertical? Well, vertical lines technically have undefined slopes. So if you say equal, it's kind of a hazy area to say undefined equals undefined. So if I gave you the one line that had a slope of 3, then its parallel line, so the slope of the parallel line would be also 3. And then perpendicular lines have negative reciprocal, I believe is the phrase that other math teachers use. You might hear me say opposite reciprocal. Reciprocal slopes. So I'm going to go back to my slope example of 3. Well, the slope of the perpendicular line, this is the symbol I use for perpendicular, is negative to make it the opposite, and then the reciprocal of that would be 1/3. And we've done reciprocal problems. Hopefully we've done enough that you understand. One thing I want to mention as well is, because it's technically not negative reciprocals, but vertical and horizontal lines are perpendicular. Okay, and the reason for that is technically the reciprocal of 0, if I were to go back to that value, 0 over 1, you would look at 1 over 0, which is an undefined value. So if you think of it that way, it does make sense that vertical and horizontal lines are perpendicular, or just draw horizontal and vertical, and you'll see that they make right angles with each other. So here's my last 2 examples. Are they parallel, perpendicular? Neither. All you have to do is change them into slope-intercept form and then compare those slopes. So if I'm looking at this first one, I would subtract x over and then divide everything by -2. So I'm looking at a slope of positive 1/2. So I really only care about this number. So then let's look at this one. Okay, well, if I subtract 2x over, well, this slope is -2 over 1. As we compare these 2 things, one's positive, one's negative, so they're negative reciprocals. These 2 lines are perpendicular. All right. And then the last example before your homework is looking at these things. So again, I'm going to kind of split it up for you. First thing would be to subtract 4x to the right side. Divide everything by -3. So we're looking at positive 4/3 x minus 2/3. Let's look at the next one. So I'm going to add 8x to the right side. Divide everything by 6. So I'm looking at y equals, this is y you want to reduce. That's 4/3 x minus 1, because if you don't reduce, you might not notice that my slopes are the same. And the other thing is, you might want to double check that the y-intercepts are different, because if the y-intercepts are different, then technically they're not parallel to each other. But in this case, the y-intercepts are different, with the slopes being the same, so therefore they are parallel to each other. And I bring that to your attention with the parallel lines, because it doesn't matter if the y-intercepts are the same for perpendicular. And if you have questions, feel free to reach out to me. Otherwise, here's your assignment, and you should be good to go.